morning. We are going to see about Z transform today. So, already we have seen linear time invariant continuous time systems using Laplace transform. That is analysis of LTI DT system using Laplace transform. But in this chapter, we will study the counterpart of the Laplace transform, that is Z transform. Laplace transform used for continuous time system analysis, but Z transform used for discrete time system analysis. The Z transform plays an important role in analysis and representation of discrete time signals and systems. It provides a method for the analysis of discrete time signals and systems in the frequency domain, which is generally more efficient than its time domain. Frequency domain analysis is always better than time domain analysis, that is efficient than time domain analysis. The Z transform will convert the time domain signal x of n to Z domain signal x of z, where the signal becomes a function of complex variable z, that is x of n will converted into x of z. So the Z transform of discrete time signal x of n can be represented as x of n. Z transform of x of n is equal to x of z. That is, the formula for that is x of z is equal to summation over n is equal to minus infinity to plus infinity x of n z power minus n. That is two-sided Z transform. That is negative side as well as the positive side. If the signal is in the positive side alone, means the summation varies from n is equal to 0 to infinity x of n z power minus n. This is one-sided Z transform. One-sided Z transform converts the difference equations. Laplace transform converts the differential equations in continuous time domain, but in Z transform it converts difference equations into algebraic equations, thereby simplifying the analysis of discrete time systems. Here Z is complex variable. In polar form, Z can be represented as Z is equal to r into e power j omega, where r is a radius of a circle. So, we can represent x of z is equal to x of r into e power j omega. In the place of z, we are going to put r into e power j omega, where r is a radius. Okay, x of n summation n is equal to minus infinity to plus infinity x of n. We know that is in Z transform, that is z power minus n. Here r into e power j omega power minus n. We can split this x of n r power minus n into e power minus j omega n. So this is the Fourier transform of x of n. Okay. So we know that represent the Fourier transform of signal x of n into r power minus n is xr of e power j omega. Okay. So we can represent this as this in x of n r power minus n is equal to 1 by 2 pi integral minus pi to plus pi x capital X of r into e power j omega n d omega. That is Fourier transform. Inverse Fourier transform of x of n. Okay. So next, in this place we have x of n into r power minus n. So we are going to neglect that r power minus n. So we can multiply r power n in both sides. So here x of n into r power minus n into r power n, we will get x of n, that is equal to 1 by 2 pi integral x of r into e power j omega. R power n multiply means r into e power j omega power n d omega. We know that z is equal to r into e power j omega. So dz is equal to, differentiation of z is equal to, here with respect to omega. So r into e power j omega will be j into e power j omega d omega. We know we want to find the d omega value. So d omega is equal to dz divided by rj e power j omega. We know that r into e power j omega is equal to z. So we can substitute these values in this equation. We will get x of n 1 by 2 pi denominator j, so 1 by 2 pi j integral over x of z r into e power j omega is equal to z. So is x of z power n minus 1 dz, where integral over c shows around the circle of the radius. Circle of radius modulus of z is equal to r. Okay. So simply definition of z transform of an arbitrary signal x of n is x of z is equal to summation n is equal to minus infinity to plus infinity x of n z power minus n. Similarly, inverse z transform of x of z is, we will get x of n, so that is equal to 1 by 2 pi j integral over c x of z power n minus 1 dz. Here z is equal to r into e power j omega. So we have to draw the circle with radius r, small r. So that is our ROC, region of convergence, where u and v are real and imaginary part of z. So real part is u, imaginary part is v. So we will get r is equal to modulus of uv. Correct? So that is equal to u square plus root of u square plus v square, where omega is the phase angle of this. So phase angle is equal to tan inverse of imaginary part divided by real part. Here imaginary part is v, real part is u. So omega is equal to tan inverse of v by u. Next, we are going to see about region of convergence, that is ROC of x of z. The transform of x of n, that is x of z. We are going to find the ROC of x of z, that is set of all values of z for which x of z attains a finite value. All values of z for which x of z attains a finite value, that is called ROC. Here some conditions for ROC that is properties of ROC. ROC is a finite duration sequence. For finite duration sequence, similarly causal, that is right side signal, ROC will be entire z plane, the whole z plane except that z is equal to 0. Except that z is equal to 0, remaining value we will get the finite answer. Okay. Similarly, for anti-causal left hand side signal, ROC will be the entire z plane except that z is equal to infinity. At z is equal to infinity, there is no finite value. Next, for non-causal signal, that means double-sided signal, ROC will be the entire z plane except that z is equal to 0 and z is equal to infinity. We won't get the finite value at z is equal to 0 and z is equal to infinity. Next, we are going to see about one simple problem. Find the z transform and ROC for the signal x of n is equal to a power n u of n. We are going to find the z transform for this sequence. So first we know that x of z, that is z transform formula, x of z is equal to summation n tends to minus infinity to plus infinity x of n z power minus n. Okay, we know that x of n, in our problem, x of n is equal to a power n u of n. Substitute that into z power minus n. Already we know in the first unit itself, u of n is a unit step function. So that is equal to 1 for n greater than or equal to 0. So unit step function having the value 1 in the positive axis alone. 0 for n less than 0. So n value less than 0 means there is no value in the left hand side. So that is equal to 0. So substitute n is the u of n is equal to 1 where n greater than 0. Substitute that here. So the limit varies from n is equal to 0 to infinity because there is no value in the negative axis. So we will neglect that minus infinity value. So limit varies from n is equal to 0 to infinity a power n z power minus n. So simplify this. a into z power minus 1 the whole power n. Summation. So we are going to expand this means what will happen? For example, we know that a plus ar plus ar square plus up to infinity, that is equal to a divided by 1 minus r. Correct? So here also a z power minus 1 the whole power n. So we are going to expand this means a z power minus 1 a z power a into z power minus 1 the whole power 2 3 4 5 up to infinity. So the answer will be here a divided by 1 minus r. Here 1 divided by 1 minus a into z inverse. Here also. So a into z inverse. In this r is less than, modulus of r is less than 1. Here a into z inverse is less than 1. That means if it is greater than 1 means the value will be negative. The denominator will be negative. If it is equal to 1 means the denominator is 0. We should get only finite value. So a z inverse should be less than 1. So modulus of a less than z. Because this z inverse goes that side means, right side means we will get 1 by z. Sorry, here 1 by z. So on that side that is z. So modulus of a less than z. So here ROC is modulus of z greater than a. So for this problem, modulus of z greater than a. So we are going to draw the circle for this. Draw the diagram for this ROC. So real part of z, imaginary x-axis having real part of z, y-axis having imaginary part of z. We know that ROC of modulus of z is greater than a means the z value should be greater than a. So we are going to draw the circle from the origin at the radius a. Okay, radius a we are going to draw the circle, but in our condition ROC should be greater than a. So outside the circle we will get the ROC. So ROC is the entire z plane outside the circle with radius a. So that is our answer. Next class we will see the another topic, that is left sided sequence. Here we saw the right sided sequence. Next class we are going to see left sided sequence.